Good morning, friends. Today we'll cover chapter 18 using object input validation. So suppose we have done the deserialization of a complete object graph, and now we want to validate the invariants of the objects. So what we mean is that we know this serialization process, right? That we call object output stream dot write object and write this stream of bytes to file, memory, database, or network. So in our examples, we have mostly been using the file. And once we deserialize it back into stream of bytes by calling object input stream dot read object, and finally we construct the object, final object, a deserialized object, which is actually a copy of the object which was saved before. So after that, before we actually start using this object, suppose we want to validate some fields, because we don't know whether the stream of bytes which has been deserialized back, it has been tampered by someone. Maybe someone has chosen this file and then tampered those bytes of streams and to just provide some insecurity holes in our application. So in that case, this validation is very important. Before we actually start using this object, we can validate some of the invariants of the field, means some of the private field members which cannot have some very bizarre value, or which can not be a very bizarre size of bytes. So this type of validation we can actually check. So we can do all this type of validation by implementing object input validation interface and overriding the validate object method from it. The method validate object will automatically get called when we register this validation by calling object input stream dot register validation from read object method. So if you look at this example, so this is how we actually register this. So in the private void read object, this should be exactly the same signature as we have been using before for customizing our serialization process and deserialization process. So we have this write object where we are calling this default write object, which will call the normal JVM serialization process. And in the read object, before we call the default read object, we call this register validation, in which we are actually registering this class as to call validate object method once it is deserialized. So once we have completed this step, so the JVM will automatically call validate object method, and then here I'm just checking, for example, one of the fields time, because time can never be negative. It's always going to be positive value. Even if you are using Unix epoch time, it should always be greater than, because it's past 1970. So this is a invariant that it can never be a negative number. And if the byte stream has been tampered and the object that we retrieve back after deserialization, that is having some bizarre value like time as negative, it means that it is not a valid object. And immediately, before doing anything useful with that object, we can throw this InvalidObjectException, giving the rejection reason here. So it is very useful to verify that stream has not been tampered with, or with the data makes sense before handing it back to our application. And if the object cannot be made valid, it should throw the InvalidObjectException. Any exception that occurs during a call to valid object, I should advise that we should not swallow it. Swallowing that, we don't do anything. We just print the tax trace in the catch and then proceed with the application. We should not do that. We should actually throw the exception and not catch it, so that it will terminate the validation process and the JVM should be shut down. So this is what we have covered in the theory part. So let's dive into IntelliJ and understand these concepts better by writing some unit test codes.